Next talk today is from Aviv Ronen from Beckermus Technologies. And Aviv's going to talk to us today about the challenges of interconnections between chips and flex substrates. Sounds good.
Yeah. Hi, everybody. The green one, yeah? Go back. Hi, my name is Aviv. I'm the CTO of Beckermus Technologies, a company from Israel. We are a subcontractor dealing with chip packaging, with all kinds of chips, materials, flexible, optic, RF, MEMS, and others. In addition to my position in Beckermus, I am the chair of two organizations. The first one is the international one, the IEEE EPS. EPS stands for Electronic Packaging Society, and I'm the chair of it in Israel. In addition to that, another society in Israel about packaging society, which is called the Electronic Packaging Branch. So my talk today is going to be about three topics. First of all, I'm talking a little bit about the chip itself, to whom of you doesn't know the world of the chip. The second topic is going to be the interfaces of the chip to the outside world. Yesterday I gave a master class for 45 minutes about the interfaces, and today I'm going to give several slides about it, just to understand that we'll all be on the same page. And the major topic of my lecture is going to be the challenges of these interfaces in the world of flexible electronics. So let's start about the chip. The chip I'm going to talk about, not these kind of chip, maybe we can see it at lunch, not these kind as well, but these kind. And I brought some samples to you to whom of you didn't see any wafer till now. This is a 6-inch wafer that subcontractor, we're not manufacturing the chip, that you manufacturing it by silicon or gallium arsenide or other materials. And after you produce the chip, you can separate it and you put it on a blue tape. And our job is actually take one chip or several chips from different kind of tapes or trays and put them onto a substrate like this, for example, okay? This is PET with copper, and we can see if somebody wants to see later on, we have several chips on it. So let's talk about the structure of the chip. Usually you have the substrate itself, could be from several materials. Then you have the core layers, the external pads that you want to connect to the outside world. And you have, of course, the top passivation. The top passivation, its purpose is to protect the cores layers. And finally, you have a discrete chip. This discrete chip can has 2 pads, maybe it has 1,000 of pads. It doesn't matter, actually. So the chip interface to the world, you have several kinds of interfaces. The first one, of course, is the mechanical. You need to put the chip into place, and you don't want it to move or get torn or sheared. The second one is electrical interface. Of course, depends how many milliamps or amps do you want to provide through the interface. Another interface that we're going to talk about the challenge is the thermal one. If your chip is getting warm and you want to take the heat and you want to dissipate it through the interface and the substrate, you need to take this outside your thermal power. So your interface has a very major role in this heat dissipation. And other interfaces from the chip to the outside world, like optical, for example. In the world of PIC, it's called photonic IC. This is one of our major goals in Beckermus Technology. We integrate fibers and LEDs and VCSELs to other chip and other components. So the interface is optical. It's very important to know how to design it and what materials to use. And another interfaces like electromagnetic interface, acoustic, and biological. In the world of biosensors, you need to integrate your chip inside a body, for example, inside the eye, and you need to choose the right materials in order to have a biocompatible, that the body will not no problem will be inside the body when you put the chip inside. So let's talk about